Welcome back, everyone. And then today we're going to start on simplifying polynomial expressions. We're going to talk about what simplified polynomial and expressions all mean. This will cover several topics, combining and multiplying and that sort of thing. We're going to start out with Z4, which is the combining, that's adding and subtracting, and then we'll look at multiplying polynomials. Z6 is when you multiply a monomial times a polynomial, and then you'll learn what that means here later. Okay, so let's go ahead and get started. Let's get rid of this. Okay, so simplify polynomial expressions in your notebook. You want to put a nice big heading, like bold it, double underline it, whatever you need to do. Simplify polynomial expressions. We need to start with, what does polynomial mean? Well, nomial sounds like name, right? Names, and that's what it is, names. Like the name for a tree is tree, but you could also say the term. The term for a tree is tree. The name, the term. So nomial means terms. Or names, terms. So poly means many. So together, many terms. That's what polynomial means, is many terms. All right, then we need to look at simplify and expressions. Let's start with a little bit of an example. So we got 3 plus 2 is equal to x. Well, we know the whole thing is an equation because there's an equal sign, but just a 3 plus 2 by itself, that is an expression just by itself. That's an expression. Could you simplify this? Could you make it simpler? Would it be something easier to write than 3 plus 2 over and over? Of course there would. You could simplify it to 5. So often we will simplify an expression on our way to solving an equation. Another example. What about 2 times 7? Definitely not an equation. That is an expression. Okay, can we simplify that? Is there something you'd rather write than 2 times 7 over and over? Of course you would. 14. 14 is a simpler version of 2 times 7. So what does this mean? This means that if you had a bunch of numbers and letters and numbers and letters, and somewhere in the middle of that you had a 3 plus 2, and then a bunch of numbers and letters and numbers and letters, in the middle of all that you had a 2 times 7, and then a bunch of numbers. And there can be an equal out here or not. This could just be an expression, or it could be part of an equation. It doesn't matter. The idea is that you would simplify 3 plus 2 down to 5, rather than writing 3 plus 2 all the time, and you would simplify 2 times 7 down to 14. That's what simplifying means. So here's an expression. Here's an expression. This is a simplification, and this is a simplification. So that's the idea behind simplifying expressions. All right, so let's go ahead and get started on Z4, which is combining polynomials. What does combine mean? It means add and subtract, but you might remember from earlier that you can only combine, add and subtract if they are like terms. And what were like terms? Well, first of all constants are like terms. What are constants? 5, 7, -2, 3/5, 0.47, -0.2. They're numbers that do not change. They're not in context of anything else. They're just by themselves. The other thing that are like terms are variables, but if and only if those variables have the same base, the same letter on the bottom, or the same number on the bottom, okay, the same letter on the bottom, and they have to have the same exponent, the same power. Otherwise, you cannot combine them. You cannot add and subtract them unless they have the same base and the same exponent. All right, so let's look at our first example. This is a binomial. This is a binomial. Two terms, and we're adding them. What you're going to see is that plus, that's really neat to see, because that means you really don't have to do anything. All that means is you can just ignore all of the parentheses. So you just write down everything as you see it. A plus B plus C plus D. Those are simple. This does nothing to change anything over here. Now, ones that you do have to watch out for are if you have a minus here. Now, if you have a minus here, that changes all the signs that come after it. All the signs in these parentheses that comes after it. So go ahead and write down the A plus B the way we see it. But what is the opposite of positive C? What is the opposite of positive C? The opposite of positive C is negative C. And what is the opposite of positive D? The opposite of positive D is negative D. So this changed all those signs. All right. So here's one for you to look at. All right, go ahead and pause it and then work it. Okay, I'm assuming you're back. So we know that we have a 4x squared. I'm going to write down everything here exactly what I say it, plus a 2x. Okay. Now remember, this changes all of these signs. So this is a positive 3x squared, now becomes a minus 3x squared. This is a minus 4, well, that changes it to a positive 4. But we're not done. Okay, so do you see any other x to the second powers? That's not, but this is. Okay, so 4x squareds and negative 3x squareds. 4x squared minus 3x squared is just 1x squared. All right, so that took care of all of my x squareds. Well, what about these x's? Okay, are there any other x's out here? X to the first power? No, so that just stays as positive 2x. All right, and then we have just a positive 4. So there we go. So now we'd had no other constants to combine that with. Now, just to call your attention to this 4 is a coefficient. This 2 is a coefficient. This negative 3 is a coefficient. Those are not constants because they're within context. They could change depending on what it just tells you how many of the x's there are, x squareds in this case. The 2 is a power and the 2 here is a power. Those are, and it'd be a 1 here that you can't see. Anyway, these are constant. That's a constant right there. This is a coefficient, this is a power or an exponent. All right, so next we'll look at how to multiply these. If you have any questions on combining, please let me know.